Hello, class. Today our goal is to start talking about an example of applying this idea of generating functions to say something meaningful about a discrete problem, namely about the Fibonacci numbers. And actually, you've seen already in a few different homework and worksheet examples that the Fibonacci numbers show up as the answer to a lot of counting questions. So you can imagine something like the domino tiling question or the sequences of zeros and ones that don't have two repeated ones question. Various of these sorts of things the Fibonacci numbers have turned out to be the answer to. So we want to see what we can say about the Fibonacci numbers by using this idea of generating functions. So I'm going to write down the Fibonacci numbers. I mean, not all of them, but enough of them. So that's these numbers. And already things get a little controversial, so anytime someone talks about the Fibonacci numbers, you have to be a little bit careful. Namely, people disagree on what the first Fibonacci number I should write down is. So should I write down 1 or should I write down 0? I'm going to write down 1, and then is the first Fibonacci number the 1th Fibonacci number, or is the first Fibonacci number the 0th Fibonacci number? Okay. So given the way we've written this down so far, I'm going to stick to this is the 0th Fibonacci number, this is the first, that's the second, and so on. Okay. Everything I'm about to do, you could readily do if you chose a different vision of the Fibonacci numbers, but I'm going to stick to that. So our whole idea of generating functions is, hey, I'm going to rewrite this as a power series. Okay, and remember again, each of these terms I should think of as telling me one of the Fibonacci numbers. So this is telling me the 5th Fibonacci number is 8. Remembering that I'm starting counting at 0, so 0, 1, 2, 3, 4, 5. The 5th one is 8. That's what this term is telling me, and every term is telling me that. Okay, now if you recall in last video, what we did is we spent a lot of time figuring out how to translate between this kind of function, this kind of power series, and a nice way of writing a function. And so at first you might think, oh, there's no way that there's going to be a nice way to write this thing as a function. But hold on, I think we can do it. And so I'm going to write down two more things here. I'm going to write down x times f of x, and I'm going to write down x squared times f of x. And we'll see what we can figure out. Okay, so x times f of x, that's going to be x plus x squared plus 2x cubed plus, and notice what I'm doing is I'm just putting the terms under their matching terms, so 1 times x is x, x times x is x squared, but I'm putting it next to the x squared term. Okay, plus 3x to the 4th plus, and then this next one will be plus 5x to the 5th plus, and so on. Okay, and this is going to be x times the previous one, so it's going to be x squared plus x cubed plus 2x to the 4th plus 3x to the 5th plus, and so on. Okay, and so a thing you might notice here is that if I start with the first line and then I subtract the next two lines from it, I get something rather clean. Okay, so I am going to imagine here that I am subtracting this and I am subtracting that. Okay, so on the left-hand side here, I get f of x minus x times f of x minus x squared times f of x equals, and then on the right-hand side, in this column I get 1, and then in this column I get 0, and 0, and 0, and 0, and actually I get 0 on forever. Because if you think about what am I actually doing when I take, say, this 8, and then I subtract 5 and 3, well, where did the 5 and 3 come from? Well, the 5 came from there, and the 3 came from there. So what I'm doing is I'm taking this Fibonacci number and I'm subtracting from it the one before that and the one before that. Okay, but what is a Fibonacci number? It's the sum of the previous two Fibonacci numbers. And so what I've literally just described to you is the process of taking a number and then subtracting that number from itself. And so, of course, I'm going to get 0. Okay. And so, in fact, in its totality, that's all I get on the right-hand side. I only get 1. Okay. So I can factor an f of x out of this. So this is f of x times 1 minus x squared. And that's going to give me just 1. And so that's going to give me this identity, which is the power series for the Fibonacci numbers, f of x, it's equal to, as a function, just 1 over 1 minus x squared. Okay. That's all there is to it. Okay. So if you expected, rightfully so, I think, this to be some horrible, complicated, messy function, it's not. It's something relatively nice. It's a rational function, even. Okay. So how is this useful? Well, technically, this function now knows all of the information about the Fibonacci numbers. Okay. Why is that? Well, every Fibonacci number contributes in a distinct way to the way this function changes. Okay. And so the 20th Fibonacci number, for example, affects the x to the 20th power term. And so that changes this value of this function over the reals by just a tiny bit, but that way is different than all of the other numbers. And so we can recover all of the Fibonacci numbers, all of the infinite information that's in the Fibonacci numbers, just from this one little function here. All right. And I want to do that just for one case. So let's say I want the 10th Fibonacci number. Okay. So what is the 10th Fibonacci number? Okay, well, that's the coefficient of, I guess I should really, by the way, have called this little f of x to follow my notation from before, because that's the function version. Yeah. What is the coefficient of x to the 10th in, okay, and I will put that in the power series. That's what that's asking, right? Because that's going to tell me this thing. Okay. For that, I need to go back to Maclaurin's theorem. And so if we pull back up our friend Maclaurin's theorem, Maclaurin's theorem was here. It said that, hey, if you want to write your nice function as a power series, then the way you do it is you put this term in front of x to the k. Okay. So namely, the coefficient of x to the 10th, it should be the 10th derivative of f, evaluated at 0, divided by 10 factorial. Okay. Wolfram alpha doesn't complain too much if you ask it to do that. Namely, Wolfram alpha will happily tell you that the 10th derivative of this thing at 0 is this number. Okay. And if you divide that by 10 factorial, you can check that you indeed get 89. Okay. If you're afraid that I cheated there, and that maybe that's not really the answer, you can go back to where we wrote down the Fibonacci numbers, and you can say, okay, what's the next one? It's 21, and then 34, and then 55, and then 89. And so that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the 10th one. It's 89. We got the answer right. Okay. Now, there are a few legitimate complaints that you might make about what just happened. So the first legitimate complaint you might make is that, well, I really did this. I actually added the numbers until I got the 10th Fibonacci number. I did not really take the 10th derivative of this. In fact, the 10th derivative of this is thoroughly horrible. And you really, really probably don't want to take much more than 3 derivatives of this by hand. In fact, even probably taking a 3rd derivative of this by hand would probably be more complicated than I could actually do, but I encourage you try it if you feel like it. Of course, a computer can take the 10th derivative, and great, but it's not super impressive that I can teach a computer to take the 10th derivative of this function in order to calculate the 10th Fibonacci number, because, of course, I could equally well, in fact, much more easily, teach a computer to calculate the 10th Fibonacci number by doing this. And so you might complain, okay, this is all true, and technically, yes, this function knows all of the information about the nth Fibonacci number, but it's not useful to us. Okay. Next video, though, we're going to do some calculus. Not taking 10 derivatives of this function, I promise, but we're going to do some calculus, some things that you did in Calc 2. And we're going to actually show some constructive information about the Fibonacci numbers. Until next time, though, be well.